A very warm good afternoon to all. I am Soumya Rajvanshi, Assistant Professor, Chandigarh Engineering College, Landra from CSE Department. Today I want to deliver the lecture on the topic Introduction to Compiler and its various phases. Before describing the phases, in phases we will actually learn about what is the actual structure of the compiler. But before going to the phases, let us first understand what is compiler. A compiler, as we know, it is a software which converts high-level language into low-level language. Now, what is high-level language? By the term high-level language, we mean basic programming language, English-like language. The main difference, the main problem of difficulty is that we human beings understand the English-like language, but the computer don't understand the same language. So there is a need of some software which convert that high-level language into the language that is understood by the computer. So compiler converts high-level language into low-level language, and it reports if there is any compilation error or not. We will learn deep about this with the help of language processing system. As I have told that any computer system, it is made up of hardware and software, we already know. The hardware basically understands a language which human cannot understand. So programs are written in high-level language which is easier for us to understand and remember. So what we do in language processing system, there are various softwares. Each have its own working. We write high-level language, suppose like we take C programming language, Java programming language. There are lines of code which are just English-like statements. So those are the high-level language. First is preprocessor. Now what does preprocessor do? We have hash include files in program. If we take C program, we have hash include, hash directives files are there. So preprocessor basically removes these hash directories file and it replaces it with some code. And after preprocessor code, source code is fed into preprocessor and the output that get is preprocessed code. This preprocessed code is, we can say, we get pure high-level language from preprocessor, and this is fed into the compiler. This compiler converts high-level language into target assembly code. But the task is not over yet because computer don't even understand assembly language also. Assembly language is nothing but the code like mnemonics. So computer don't understand that also. So this assembly language is further fed into assembler that converts assembly code into relocatable machine code, or we can say target code, that is output that is understood by computer. This is basically the binary code which is understood by the machine. So preprocessor, then compiler, then is the working of assembler which converts it into machine language. This machine language is now fed into linker and loader. What is the working of linker and loader? Linker basically links all the object modules together as a single unit, and loader loads the program into the main memory. It is needed whenever we need it, it is just appear at that time only, and it links all the library modules, and finally we get the executable machine code as the output. Let us understand it further also. See, for example, if we are taking a C compiler, if we are taking any language such as C program, so C compiler is there. We write a language, we write a program in C language which is a high level language. So first comes the preprocessor which removes all the directives, hash include, hash files, and it converts it into the pure high level language. Then comes the C compiler which compiles the program and translates it into assembly language program which is low level language. But it is again a assembly language which is not understood by the computer. So this assembly code is fed into the assembler and that translates the assembly program into the machine code. That what I have understood, that what I have of the flowchart. So let's move further. See, these are the definition. If we talk about the main functions of the preprocessor, so preprocessor basically performs functions like macro processing, augmentation, file inclusion, I can say, or language extension. So first portion is clear, the working of preprocessor. Then comes the compiler. Now, what is the basic, the question comes, what is the basic difference between the compiler and interpreter? Both basically translate high-level language to low-level language. But compiler reads the whole source code at once, create tokens and check semantic. But in contrast, the interpreter reads a statement from the input, converts it into line by line. Statement by statement execution is done by interpreter, but compiler, what compiler do? It compiles the whole program at one go and report any error if there is any error format. So let's move forward now. Linker, loader, I have already discussed its functioning. Linker, what its major task is to link. The basic task of the linker is to search and locate reference files. And what is the function of loading? It is responsible for loading executable files into memory. So next comes the compiler design architecture, or I come to say its phases of the compiler. So basically, compiler works in phases. What is a phase? A phase is a logically interrelated set of statements which takes input in one form and converts it and gives the output in some other representation. So basically the compiler is divided into two phases, analysis phase and synthesis phase. This analysis and synthesis phase is further divided into subphases. So if we talk about the major difference between analysis phase and synthesis phase, what is the major difference between that? Analysis phase is known as the front end of the compiler. It is the front end of the compiler, and the basic features of analysis phase are that it is machine independent but language dependent. We will learn three phases in analysis phase, which is lexical analysis, syntax analysis and semantic analysis. Then comes the synthesis phase. Synthesis phase creates the target program with the help of intermediate source code representation. It also has two phases. The main features of the synthesis phases are that it is machine dependent but language independent. Both are reversed. So as I have told you that compiler works in phases. What is a phase? Phase is a stage which takes input from the previous stage, processes it and gives output in some other representation. Takes one representation and produce output in some other representation. That is a phase. And the complete traversal of the compiler through the entire program is known as pass. Phase is a different stages and the combination of various phases which a compiler travels through its lifetime, that is known as its pass. See, this is the phases of the compiler: analysis phase, synthesis phase. Analysis phase is known as front end of the compiler and synthesis phase is back end of the compiler. The source program is fed into the analysis phase. It transforms into some form and we get the intermediate code representation. After that, this intermediate code representation is fed into the synthesis phase and the final output we receive is machine code. So this is the entire working of the compiler. Now, if we come on the phases of the compiler, there are 6 phases of the compiler in total. Each has its different representation, and as I told you that each phase takes input from its previous stage, has its own representation of source program and feeds its output to the next phase of the compiler. Takes one program, give some representation and provide output to some another phases. So this is the general structure, or we can say phases of the compiler. Source code is fed into lexical analyzer, then syntax analyzer, then semantic analyzer, intermediate code generator, machine independent code optimizer, code generation, and last is machine dependent code optimizer, which is the target code. All these phases are connected to error handler. What is the functional? If we are getting any of the error, like we get any syntax error or semantic error, we report to the error handler. And what the symbol table? Symbol table actually keeps the data structure. It contains all the data structure, all the identifiers, all the keywords, whatever are needed, we can take it from the symbol table. So it acts as a data structure of the compiler. So let us understand each phase one by one with the help of a short example, and then in final I will explain the entire functioning with one single example also. So first phase is lexical analysis. Lexical analysis, as I have told, it is the first phase and it works as a scanner. Scanner means it reads the whole source program, characterizes it and forms the meaningful lexemes. These meaningful lexemes are represented with the help of tokens. And what is the general structure of the token? That it contains token name and the associated attribute value with it. For example, if I have taken new value is equal to old value plus 20. Now what is the statement? Is nothing but just a program like C program or Java program. It is just simple statement like that. So what are the tokens? Tokens I have identified. New value is an identifier, it is a token. Again, old value is a token. But between that, there is an equal to sign, that is assignment operator. It is also considered as a token. Then we have plus, it is also an addition operator, it is also considered as a token. And 20, it is a constant number which is also a token. So in general, if this line I consider as a program, then we have total 1, 2, 3, 4, 5 tokens. So these sequence of tokens is produced as the output of lexical analysis, which is fed as the input to syntax analysis. This line is converted in some form and that form is fed into the next phase. This is the main working of the compiler and its phases. So the second phase is syntax analysis. What is the function of syntax analysis now? Syntax analysis is also known as parsing. Why it is known as parsing? Because the word parser is connected with it. We get the output from syntax analysis, a parse tree, or we can say a syntax tree. Input is token and output is a syntax tree or parse tree. Now let us see how this tokens is converted to syntax tree. If we take the same example, new val is equal to old val plus 20. So the syntax tree will be considered like this, is equal to, we have identifier here in left and expression in right. This expression is further divided into, if I say expression plus expression. And what is this expression? It is basically old value, which is a identifier. Expression is number or constant value, which is 20. So this way the syntax tree is represented from this lexical analysis phase. Okay, so if I take about this is a syntax tree, syntax analysis output. That is the thing. Next phase is semantic analysis. Semantic, as the word indicates, semantic basically checks whether the parse tree conducted follow the rules of language or not. For example, if I take sum is equal to int a plus float b. So if I consider this statement, is this statement possible? No. Why? Because the data types are different and mismatched data types are not allowed. So one of the data type needs to be converted to form compatible data types. So if I take sum is equal to double, suppose A I have taken int, B I have taken float, so it is not possible. So semantic analysis basically checks that rules of language are followed or not, if whether it is having a compatible data type, and if there is type mismatch, it converts the grammar into that type so that equal types can be taken, compatible data types can be taken. That is the functioning of semantic analysis. So till here we are having analysis phase. After analysis phase, intermediate code generation is the phase that bridges the gap. It basically bridges the gap between analysis and synthesis phase. We get intermediate representation as the output of analysis phase, and this intermediate representation is fed into synthesis phase, which is machine dependent phase. Okay, so this is intermediate code. And what is the basic functioning of intermediate code? Let us explain with the help of a small example. Suppose I take some new value, I say new value is equal to old value plus rate into 1. So firstly this is to be converted into tokens, which is id1 is equal to id2 plus id3 into 1. Now what the intermediate code generation do? It basically assigns temporary values. Temporary values are assigned. Suppose if I say temp1 is equal to int real 1. temp2 I say id3 into temp1. In temp3 I have id2 plus id3, and finally id1 is equal to temp3. So temporary values are given to the code. This is the functioning of intermediate code generation, and with this our analysis phase ends. So let's come to the synthesis phase now. In the synthesis phase we have basically two main phases. One is code optimization and another is code generation. So for code optimization, as the word indicates, optimization. As the word indicates, optimization means to improve the code quality. And how we can improve the quality of code? Like intermediate code generation, we got intermediate code generation. We have to improve that intermediate code by removing unnecessary lines of code and arranging a sequence of statements so that our program can run faster, our program can take less space, and it can be executed in the best amount of time. So if I take the previous example, we have id1 is equal to id2 plus id3 into 1. We have taken 4 temporary values in the previous example. But here I can remove the unnecessary lines by taking temp1 is equal to id3 into 1. And in second line I can take id1 is equal to id2 plus temp1. So this way the 4 lines of code is converted into 2 lines of code. This is the functioning of code optimization. In this way the code is optimized, the length of the code is reduced, the output can be better as it takes less memory. So this is the optimized code we have received after code optimization. The final stage of the compiler is code generation. This is the phase in which we get the final relocatable code, or I can say my assembly language code, because as discussed earlier, it does not produce the machine level language code. Compiler basically gives output as assembly code. So what it do? It gives the assembly code as output. And what is assembly language? Assembly language is basically a mnemonics like code. So if I take the previous example only, id1 is equal to id2 plus id3 into 1. So what it assigns registers. We write move r1 ID3, then multiply ID3 with 1, then we assign move ID R2, ID2, then I write add R1, R2, and finally in ID1 I have to store R2 value. This is the functioning of the code generation phase that we get output in the form of mnemonics or the assembly level language code. This is the code generation. So these are the various phases of the compiler. In the compiler, next videos we can see each phase in detail. Like lexical analysis, its workings, how the syntax analysis, there are various parsing techniques and so on. But this is the basic structure of compiler and the basic functioning we can say of compiler. In the last slides, let us brief our discussion with the help of the symbol table. Okay, symbol table I have told that it is basically a data structure that maintained throughout all phases is the symbol table. And this is the example as the output. We can say we have taken one example to brief our discussions of the phases of the compiler. So basically, firstly we have taken the example sum is equal to old sum plus rate into 50. This is what the English like statement we get. These are the English like or code we get as the input. It is fed into lexical analysis. The output of lexical analysis is tokens we get. So tokens we get in the form of ID1 is equal to ID2 plus ID3 into ID4. These are the tokens we get from lexical analysis. These tokens are fed into syntax analysis, and what we get the output as syntax or parse 3. It is created like this is equal to ID1 plus ID2 into ID3 and ID4. This is the syntax analysis. Then is semantic analysis. It checks for type. So we get outputs as semantically correct parse tree as the output. So if any type conversion is needed like this 50, it is converted from type int to real. This is the functioning of the semantic analysis. Last we come intermediate code generation. Analysis phase is completed. For synthesis phase, intermediate code generation. What we do in intermediate code generation? Temporary values are assigned. So temporary values temp1 into real, temp2 multiplication, temp3 we have done plus, and ID1 we have assigned finally temporary 3. So this is the intermediate code generation output. Code optimization, we get outputs as optimized code. The previous code that we received from intermediate code generation, it is optimized in the code optimization phase. These 4 lines of code is converted into just 2 lines of code. This is the optimized code. And finally is the assembly language code. This is the output of code generation phase, assembly code. So in this way, the working of compiler is done from lexical analysis to code generation. Next we will meet in some other videos. Thank you.